Hi and welcome to our first level 2 video on calculus. In this video we're going to focus on how to differentiate a polynomial. Differentiation is the process of taking a function, which is a formal word for an algebraic rule, and turning it into what I like to call a gradient function. For example, we're going to take a function y equal to x squared plus 4x and differentiate it into the gradient function, which we're going to call y dash, which is equal to 2x plus 4. The gradient function is called a derivative. Here's some of the notation you need to be confident with. The informal notation, y differentiates to y dash. The formal notation says y differentiates to dy over dx. And one other type of notation you need to be familiar with, if that's the name of the function, this differentiates to f dash x. Okay, let's get into some rules. If we have x to the power of n, this differentiates to n times x to the power of n minus 1. So the n comes out the front and times us by the x, and we take away 1 from the power. For example, x cubed differentiates to 3x squared, because the 3 comes out the front and the 3 drops down to a power of 2. If we have a number a out the front of our x to the power of n, this differentiates to n times a times x to the power of n minus 1. So the n comes out and times us by the a, and we still subtract 1 from the power. For example, 6x to the power of 5. The 5 comes out the front, times us by the 6 to get 30, and we still take away 1 to get a power of 4. If we have a number by an x, this just differentiates to the number a. For example, 5x will differentiate to 5. And any number by itself just differentiates to 0 and disappears. Right, here's our basic rules. We're not going to prove them in this video. We're just going to get used to how to use them and what to do. Alright, example 1. Let's get into how to differentiate this function. Y is equal to x to the power of 5 plus x cubed, take away 6x plus 2. So we're going to turn it into dy dx. The 5 will come out the front of the first term and we'll take 1 off the power of 5. In the second term, the 3 will come out the front and we'll take 1 off the power of 3. The minus 6x will differentiate to minus 6, the x disappears, and the plus 2 differentiates to 0, which will disappear. So when we tidy it up, we get dy dx is equal to 5 times x to the power of 4 plus 3x squared, take away 6. Alright, example 2. Let's differentiate this function. Y is equal to 7x cubed plus 4x squared minus 5x plus 9. We'll use the informal notation, y dash. Now the 3 is going to come out the front of the first term and times by the 7, and we'll take 1 away from the power of 3. The 4x squared, 2 will come out the front and times by the 4, and we'll take 1 away from the power. The minus 5x will differentiate to minus 5, and the plus 9 will differentiate to 0. So when we tidy this up, we get y dash is equal to 21 times x squared plus 8 times x to the power of 1 minus 5, but we don't need a power of 1, so we'll tidy it up and write it as 21x squared plus 8x minus 5. Right, let's look at example 3. Differentiate. Y is equal to 4x cubed over 5 minus 2/3 x squared plus x. Well, we need to know that there's a 1x here. And let's differentiate the first term. The 3 comes out the front, times us by the 4, and we take 1 off the power. It's still all divided by 5. The next bit is 2/3. The 2 will come out the front and times by the 2/3, take 1 off the power, and the 1x will differentiate to just 1. So when we tidy it up, we get y dash is equal to 12x squared all divided 5 minus 4/3, because 2 times 2/3 is 4/3, times x to the 1 plus 1, but we don't need the power of 1. Great, thanks for watching.